Hello, my name is Pheaknavong CHIM. I'm from the Crossmark team in the Spaghetti Bridge competition.
Hello, my name is Panhavireak and I'm from Crossmark team.
Hello everyone, my name is Chihok GAUY and this is the video report for ENGR 101 from the Spaghetti Bridge Challenge.
Before the development of the project, we each individual researched and came up with many sketches of different brick designs. And we did a variety of contents from informal written article to the video that record for the perspective competition. And after that, we gathered to discuss all the bridge that can be designed with our material that have included in the rule, and so it boiled to down to two available designs to choose from, which is arch bridge and the truss bridge.
Initially, we opt for the truss bridge. First, it is very easy to put together without micro measurement or the management of many pieces or components to put together. Second, its compression and tension diagram is simple to understand, with each beam responsible for either the former or the latter. Finally, we see it being used in real-life situations and also in competitions. Although truss bridge is great, we eventually stumble upon the arch bridge. This was heavily inspired by the Sydney Harbour Bridge in Australia by the Opera House. We found that the arch bridge is more resistant to bending force since it is already curved. In contrast, with the truss bridge, where the straight beam is more prone to snapping when it is compressed, now we do use small straight beam pieces to build the arch bridge, but our concept is that we put each segment in constant compression while the deck is in tension. Along with the more aesthetically unique design of the arch bridge, we were sold on the idea of an arch bridge.
As I've mentioned previously, we chose the arch bridge over any other bridge. And for the arch, we chose a parabola shape or a half ellipse shape rather than a semicircle, because the parabola shape would handle the load better than the semicircle. And the semicircle would be better if the competition criteria says that the load comes from a single point, which is the middle, the center point. But for this competition, the load comes from a span of 45 centimeter, that is the length of the testing block, and the weight should distribute evenly throughout the bridge in the span of 45 centimeter in the 60 centimeter gap. We also had both the arches leaning towards each other rather than standing perfectly vertical, because that would prevent any swaying motion if we calculate the dimension correctly, of course. We left a gap on each side of the bridge because we did not want to put a burden on the weight to load ratio that was in the criteria of the challenge. That is because the testing block is only 45 centimeter and the gap between each table that we have to put the bridge on is 60 centimeters. So even if we put some deck bridging on each side of the gap, that would not have any benefits for the bridge. It would only make the bridge heavier. We also kept in mind to put a opening in the middle of the bridge, because that's where the testing hook that is attached to the wooden block would go into, and that would give access for us to put a bucket on the hook and put weight on there to test the bridge. We also put 4 additional diagonal beam on each side of the bridge for both arches, and that is for load distribution purposes, and it is also for both sides of the arch to not bend outward too much, which would cause the bridge to snap. However, we did notice a flaw after testing the bridge, which is that we needed to put additional diagonal beam on each side of the bridge on both arches to support it from further bending outwards, but we forgot that, so it ended up with the bridge curving outward and eventually snapped. However, the bridge was able to withstand a load of 32, almost 33 kilograms with a weight of only 1.1 kilogram. After building the bridge, we were expecting it to carry a load of 34 kilograms, but it ended up being 32 kilograms, which was really close to what we expected.